Let's get it on tape. We like going to Goodwill for books for my kids. I don't know if you ever go for like little kids books. So we go there and I see other books, right? Just random other books. And 3 books caught my attention, but one of them I started reading this weekend. It's called Cellular Biology. Okay, so it's cell biology. It caught my attention, right? All right, good. It's not a novel. It's not fiction. It's nonfiction. It's actually a textbook. But as I'm reading it, guys, they're talking about cells. You guys know cells are really small?
Yes.
And you can actually measure how long parts of the cell are. But you don't use a ruler like we use. You use either electron microscopes or you use like different types. They have different types. And the units are very, very small. And they're like, how do you describe that with our type of numbers? Like, how do you say that's this many inches? Like, how can you compare it? You use scientific notation. So throughout that book, in the first chapter, I'm seeing a bunch of numbers in scientific notation. I'm like, oh, I wonder if they didn't have scientific notation, would they just have to write it in standard form? So we're going to look at standard form, which I hope you know is just how you normally see numbers. And then we're going to look at scientific and convert between the two. And then you tell me if scientific notation's worth it. Like if it's, should we learn it or should we just do standard form every time? So we'll look at them. Before you ask questions, is it about scientific notation or about something else?
That book in the kids section?
Well, sorry, there's a kids section and I start looking at the other section. Yeah, it was not in the kids section. And if it was in the wrong place. Yes.
Didn't you also just say like this many like nanometers or whatever?
Yeah. And so you start using, and then you start looking at what is a nanometer. It's a millionth of a meter, or a I forget the small unit. It's like a billionth of a meter, like billionth of a meter. Yeah, you're going to use scientific notation to describe that. Okay, let's look at the format. So you're going to write this form out. Excuse me. And all scientific notation numbers, if they're written properly, will have this form. A times 10 to the nth power. A times 10 to the nth power. It has to look like that. But these numbers, A and N, are certain numbers. Where A is greater than or equal to 1, and A is less than, less than 10. So A, the number A, whatever A stands for, has to be greater than or equal to 1 and also less than 10. Has to be in between 1 and 10. That's kind of how you can put it. And N is a special type of number. It's an integer. Good. It has to be an integer. So you're not dealing with halves, mixed numbers for N. It just has to be a whole number or its opposite, okay? That's scientific notation. So that's the standard format. And by the way, I'll do this. I'll ask, is A in between 1 and 10? And if you can say yes, you're part of the way through with scientific notation. If you say no, that means we have to convert it. And that's basically what going to scientific notation does. Okay, let's look at our first problem. And these problems are going to deal with standard. So in your notes, you can write standard to scientific. All right, so how do you go from standard to scientific notation? You've done this before, by the way. This is not new. Hopefully it's not hard. All right, 396,000. Why do I say that standard form? Do you guys remember? Why do I say standard form? Because that is the way. Yeah, and that's the way we normally see numbers. Even like first grade, you can look at that number and say, oh, okay, that's a big number. 396,000. That's standard form. I want to get to scientific notation. I want to get it into the A times 10 to the nth power, where A is in between 1 and 10, and N has to be an integer, right? I'm going to go back to that definition. Okay, is this number between 1 and 10? No. Okay, the decimal point's over here. In fact, it's really, really big. So where do I have to move that decimal so that this number is between 1 and 10? You guys remember? Yeah, Justin? 1, 2, 3, 4, 5 times to the left. So my number became 3.96, but that's not the actual value. I have to put in times 10 to the... How many times did I move that decimal? 5 times. Now, The question is that 10 to the positive fifth or 10 to the negative fifth? And I remember growing up, guys, I remember thinking, if you move it to the left, it's positive. If you move it to the right, it's negative. And that worked okay until I had to go from scientific to standard. Then you have to think backwards. Wait, if you go from right to left, not left to right. Okay, here's how I do it. I taught this now for a couple years. Okay, is 396,000 a big or small number? Remember that from last year? Is it a big or small number? It's big because it's greater than 1. So if it's a big number and I convert it to scientific notation, this has to be positive. Okay, that's it. You take that to the bank every time that works. So this is scientific notation. And you don't have to write positive.
So big to small is positive, and then small to big is negative?
Well, yeah, that's where the way I described the other way was this a small number? And we'll say yes. If it's a small number, negative exponent. So you could say that, but just keep in mind what I mean by small to big. I don't want to make that confusing. Say that again?
Big is 2 to infinity.
Yeah, or even like technically 1 to infinity. Yeah, anything bigger than 1. 1.5, same thing. Okay. Yeah, so 0.7, is it bigger than 1? So it's a small number, we're going to have a negative exponent. That's how it works. Okay, let's go with this one. Speaking of small numbers, 0.0125, 125 10,000ths. Okay, is that a big or small number? According to our definition of comparing it to 1, small. So is this between 1 and 10? Nope, it's too small. Where do I have to move that decimal point? Twice, right? So it's going to come 1.25 times 10. I moved it twice to the negative second because it's a small number. So basically, when you look at numbers in science, because you guys will, by the way, chemistry, cellular biology, when you get into cells, they're going to say, this is how big it is. You're like, what does that mean? It means it's a very small number. Or they might have times, if you have like earth science, when you start talking about space as well, big numbers, that's very far away. Okay, so here's your scientific notation. Ready? Matthew, is this number between 1 and 10?
Yes.
Elijah, is this number an integer?
Yes.
Okay, does this number right here represent the same number I had up there?
Yes.
Yep, they're the same. They just look different. Why do I use scientific notation? What do you think? Yes, it does.
Are there any big or small numbers?
Big and small. By the way, guys, this is funny. One of the sixth graders, he came, I had early say, he came to me and he was like, Mr. A, what's the square root of 50 billion? It's like 50. I was like, what? Where does this come from? So I write it down. I write it down because I want to see the number. Like, oh, okay, if you break it apart. Okay, if I wrote it in scientific notation, you can actually find the square root of 50 billion by splitting it up into 5 times 10 billion. You're like, 5 times 10, but that's a lot of zeros. Isn't it a lot of zeros? How many zeros, by the way?
A lot. 7.
Close.
10.
10 zeros. 10 zeros. That helps me to get the square root very quickly. Boom.
What is it? Backward.
200, the exact is 223,000. I just said 200,000. But then I looked at it. No, he was just asking. He wanted to know. Why he wanted to know? I don't know. I should have asked him about that.
Because you wanted to know.
No, yeah, I don't know. Huh? Okay, yes. Now let's go from scientific to standard, yeah. And this is where, again, if I said right, you go positive, left, you go negative. Then you have to switch it up, and then you forget which way you have to go. Let's just deal with it this way. I have a number, 2.98 times 10 to the 5th. Somebody tell me if that's a big or small number.
Big.
It's a big number. How do you know it's big? Positive exponent. Positive integer right there. Okay, so here's what I have to do. I want to write it in standard form. So I have to move the decimal 5 times. Which way? You have 2 choices. You can go to the left or you can go to the right.
To the right. Right. Left would make it
Right.
a smaller number.
I mean, correct. Right. Low. Yes. Okay. Listen, guys. If I moved it to the left, won't I get like 0.000298? That's a very small number. That's not accurate. So 1, 2, 3, 4, 5. What do I do with those extra spots? Yeah, good job. 1, 2, 3. Put the comma where it belongs. We like commas. You like commas, by the way. If I gave you numbers without commas, you're like, I got to put the commas in to read it. Then just put it in there to start. Yes.
We don't put commas on like a quiz or something when you count off.
I will mark it off. Good question. Oh, man. No, it is. But part of math, guys, is not just getting the right answer. But just like when you have to show your work, which is justifying it, you also have to communicate it. Like if I had the right answer up here and I say something that's not correct, I knew it, but I didn't communicate it. So it's really no good because I can't tell people what the answer is. Part of that is, put a comma.
No, but if you knew it, you wrote the right answer down, but you just didn't put the commas.
But so again, I look at it, I'm like, wait, comma. Okay, got it. So you made me do more. You made me do more.
What if you did like a space between?
Space, all right. Any other suggestions? Okay. Yeah, I'll mark it wrong. Okay. 7.08 times 10 to the negative third. Big or small? Small. It's got to be small. Negative exponent. Okay. Move that decimal 3 times. Which way? Left. Again, if you moved it to the right, 1, 2, 3. It looks good. That's not too bad. But it's a big number. You wanted it to be small. So 0.12708. That's standard form. That's how you normally see a number. How many of you are good with that? How many of you are like, yeah, Mr. Ray, we've done this so many years now, right? So I hope you're getting better at that. Excuse me? Who said that? 1.37. I'm going with 37. I'm sticking with it. 1.4. 1.414. That sounds right. 2.7, 2.675.
2.675?
Actually, can I tell you the truth? I remember when I was in high school, and then I had my friend's brother, younger brother. He would come up to me and ask me something similar. What's the square root of 15? I'm like, and I had to give an answer. I had to guess, and I would get it pretty accurately because I kept doing it. Yeah, I just kept practicing. And then I told you guys last story, and then I'm sorry, guys. I got to keep going. Yeah, when I coached cross country with some of you guys, like right here. Let's see who was in that cross country. Elijah, Andrew, who else? Let's keep. I'm gonna keep going here and be quiet. Let's do that. Dylan, I think you're in there.
Andrew.
It was a tough year. How about that? Because I was on it. No. You're good, William. All right. Anyway, when you guys were at one of your meets, so as a coach, you're kind of just waiting for you guys to come back around. And at the meet. So I'm there and I have my clipboard. I'm recording your times for the first. I think it was the first lap on that case. And then I'm like, square root of. I just picked the number, square root of 15. So I start estimating. I'm like, 3.8. And then I went 3.8, and I tried to see, can I get closer to 3.83? So I do the math. 3.83 times 3.83, work that out. 3.84, I worked that one out. It's closer to 3.83. So I guess 3.834 or 2, work that out. I was just doing that while you guys were running laps. Just doing it. I had a paper full of work. I'm like, Swivl, do not record this. Yes, it was fun. It's because you're getting it. No, because I'm practicing. Am I a what? No, not at all. Okay, let's do this. I'm going to go with this, guys. I didn't do this last year. I'm doing it this year because I want to make this more of an honors. Okay. To add, we didn't do adding or subtracting scientific notation numbers. So to add and subtract in scientific notation. I'll just be honest with you right now. Not only is scientific notation useful for writing numbers down, like it's easier to look at. Well, it's not as long as I thought. But it's also easier to add and subtract and multiply and divide. It's easier to use scientific notation. I'll show you in just a bit. But let's look at adding and subtracting. Here's the problem. 9.7 times 10 to the 5th plus 7.3 times 10 to the 5th. Okay, that's an addition problem. Okay, please be careful. You're trying to add this and this. Okay, you're adding those two numbers. Are they both in scientific notation?
Yes.
Yes. Proper? Are they proper? Ooh, 9.7, is that between 1 and 10? Okay, good. Is 7.3 in between 1 and 10? Okay, good.
What if it's
You-
over 10?
If it's over 10, you can change it. So like if it were 10 let's say 10.2 times 10 to the 5th, because you will get this in a future problem. So I want to move that decimal where?
Oh, yeah.
Once to the left. Okay, and you're like, which way is left? Is that positive or negative? Wait, was 10.2 greater than 1?
Yes.
So it went up 1, so it becomes 1.02 times 10 to the
40.
sixth. We'll practice that. Good question. Okay, anyway, look at these two scientific notation numbers. Do they both have 10 to the 5th power? Do they have the same power of 10? If yes, you can just add these two numbers together. Boom. Add those two numbers together. So 9.7 plus 7.3, 10, 17.0.
Yep.
So you get 17 times 10 to the 5th. Right? You just add those two numbers together. But is that proper?
No.
All right, so let's see if you... So that is correct to do. Is my answer proper? I'll make that clear. Is my answer proper? No. Okay, so change it to make it proper, and then I'll ask one of you lucky individuals what the proper correct answer is. Really, you have two choices. I think everyone's going to say 1.7. I hope everyone says 1.7. Everyone's going to say 10, but the power you choose will determine whether you're right or wrong. By the way, it'll be off by 100 if you go one way or the other. It's off by 100 times what the number is actually. That's a lot. Okay, let's go with, yes, I see that hand. Josiah.
I put 6.
6. Okay, hold on. Why is it not 4? Because I mean, that's the other way you can go. Why not 4? Someone tell me why not 4. Yep.
Well, you're making 17 smaller. It's okay, Joe. So then when you multiply, it has to get bigger again. Smaller.
Okay, that's a good, I would just say, is this number bigger than 1?
Yeah.
Is this bigger than 1? So you do move the decimal point once, and since it was a big number, you go up 1. Okay, so 1.7 times 10 to the 6th. Okay, that's all I'm going to talk about with adding and subtracting, because I'm not going to make it do too many problems like that. Let's look at the last part. Multiply or divide. Yes. And this will be it. Multiply and divide in scientific notation. Whoa, are they serious? Oh my goodness. Ah, man, I'm so sorry. Well, no, I'm not sorry. Okay, yes.
If our number is already between 1 and 10, then
You just leave it alone? It was correct, yep. And that happens. You might get where it's just exactly. All right, here's our multiplication problem. I'm going to point out some similarities and some differences. What are you multiplying? You're multiplying this number by this number. Okay. But you're also doing other multiplication. Do you guys see the multiplication right here?
Yes.
Do you guys see the multiplication here?
Yes.
And what property says I can multiply in any order when I'm multiplying?
Commutative.
Commutative. Oh, it's been a whole year. Actually, 3 months. Okay, 3 months
It's only been 3 months.
since you last saw me. I know. I've gotten taller.
Wait, it's only been 3 months.
Really, I have.
You care about the show.
Okay, listen. Doesn't matter the order when I'm multiplying these 4 numbers technically, based on that commutative property. Can I multiply in any order?
Yes.
Yes, I can. So what I'm going to do is this. I'm not worried if I have the same power of 10. It doesn't matter when multiplying or dividing. But I am going to multiply these two first and then these two second. So first multiply 6.1 times 2.3. So multiply those out. Get a number. Don't forget your decimal point and where it belongs. Okay, I got 14.03. 6.1 times 2.3. 14.03. Okay, and just leave it like that for now. Let's see if you guys remember. It's been a whole weekend, 3-day weekend. Plus a quiz. Plus review. So it's been a while.
When do we get our quizzes?
So like 6 days.
It's okay. Yeah, you'll get it tomorrow. Lord willing, you'll have it tomorrow. Okay, I'm going to multiply 10 to the 7th by 10 to the 4th. They have the same base. You're multiplying them. What do you do with those exponents? Add them. You get 10 to the 11th. Yay, I did that part. Remember, multiplying same bases, you add the exponents. That's the law of multiplication for exponents. Okay, but is that the correct answer? No. Anna Grace, why is that not correct? It looks so good.
Is the exponent involved?
Because the exponent? I mean, that looks good. I think it's an integer. I'm allowed to have it, but what's not so good?
The decimal?
Yeah, is this right here a number between 1 and 10?
No.
No. So I got to move that decimal once to the left. Makes it 1.403 times 10 to the 12th. That's the correct answer.
Wait, we don't have to figure it out.
Well, you could convert to standard. Go ahead and do it. Go, standard form. You're welcome. No, will. In the assignment says, write your answer in scientific and standard form. Thank you for the reminder, though. I needed that. It's too late. I just had lunch. Remember, blood vessels, they're active. Yes. Oh, you have an answer? Hold it. By the way, is this a big or small number?
Huge.
Big, huge. Yes, it's a big number.
Absolutely large.
By far, yes. Okay. We will go with Sophie. When you're done, I need the answer. Say that. No.
What is the number? Trillion?
I've heard of quadrillion, quadrillion, quintillion, 5, heptillion, hextillion, heptillion, octillion, nonillion. That's a lot. Nonillion. I don't think that's it. I think it might be, but I haven't gone that far. I haven't counted that far yet. Huh? I think it's something else like decillion, I don't know. Don't ask me. Swivl, I don't know. Okay, but we can figure it out. Google has 100 zeros. That's 100. Yeah. That's a Google, I think. Yeah. I only Google when I'm looking for stuff, so I'm not sure. All right, Sophie, no pressure, but here's what I'm gonna do. I'm gonna write 1403. How many zeros after that? Do you remember? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, before you do anything, guys, look at the board. Look at the board. Don't look at your paper. What's that number? Don't look at your paper.
1 zillion.
Guys, you know what's gonna help you out?
1 quadrillion.
Commas.
Oh, all right. What is it, Justin? Read it off.
1,403,000,000,000.
Period. Yeah. 1,403,000,000,000. That's it.
Yeah, that's right, kid.
I'm a zillion.
How many of you, after I put the commas, were like, "Oh, okay, just got to find that place value"? Yeah. That's what you did. I'm sorry, but that's what you did. Last problem, but not least. Wait, hold on. Did I write that? Thank you. All right. Okay, there we go. Swivl, look at them. Yep, yeah, got them. 4.731 times 10 to the 8th. Oh, that's not too bad. It's a big number. Not too bad. Divided by 5.7 times 10 to the 3rd. All right. I'm not going to tell you what to do. I want you to work it out. And you can work in pairs or you can work in groups of 3. Only your 3. Andrew, you can pick either group of 3 back there. It is not 1 zillion, by the way. It's not going to be 1 zillion. Nope, I'm going to let you guys think it through.
Wait, so what do you do? 5 on 1.
Talk about it, guys. You're allowed to communicate. You are allowed to talk.
Are y'all like subtracting?
So do we really have to divide?
Yes.
After the actual division?
You are allowed to communicate. You may talk. I'm allowing you to say something to your neighbor. Starting now. Yes, you may do it.
I just don't even feel like dividing that.
So you need to be asking your neighbor, what do you think I can do? Maybe you said the same thing. Oh, let's try it out. Maybe you said opposite things. Uh-oh. Maybe you don't even know what to say. That's not too bad. I need a confident group to tell me what they did. Confident. Not right. Confident.
I'm confident about the exponent.
Oh.
I'm very confident.
So you're confident about part of it? All right. Who's confident about it all? Help me out. I forgot to write this in my notes. Oh.
I got it.
Oh. Variety of answers here. I don't know if some of them might maybe good, some of them may not. What do you know to do? Drew.
Divide.
Divide what?
4.231 divided by 5%.
How many of you divided this right here? All right, this is your division. Is it 8.3? Is it 8.3? Okay. Oh, you got that part. Good. That is the first step. 0.83. How many of you knew what to do with those powers of 10?
Yes.
Michelle?
You subtract.
Subtract what?
The exponent.
The exponent. So they're being divided. So you subtract the exponents and you get 10 to the fifth. 8 minus 3 is 5. Great.
Did it and divided?
You could have, no, really, you could have done it, but did you write the problem down like that?
Yes.
Was it nice to look at? Because you can get the right digits, but you get the wrong place value. All of you got 10 times less or 10 times more what the problem was the answer was actually. So be careful with that. But you could, yes, you could. All right, I got to move my decimal. That's not between 1 and 10, so I move it once to the right. It becomes 8.3 times 10 to the
4.
4. Whoa, wait, I thought we were going up every time.
No.
Small number makes that power go down. So times 10 to the 4th. How many of you got that? How many of you got that before I told you? How many of you got that when I told you? How many of you got that after I told you? How many of you still didn't get it? It's right there. Okay. Hey guys, you know how to do things because you understand a little bit about math, don't you? Did I have to tell you how to do it? Some of you know. Some of you, yes. Some of you, I still need to tell you. Okay. Here's what I want you guys to do. On the try these. Oh. Dare I say you do number 1. No, just for now. Do number 1. Do number 1 on the try these. Page 15. I don't mind assigning these for homework. Try these number 1.
I read the book.
No, don't write in the book. No. You just erase it, please. Thank you. Page 15, number 1. 751 billion.
Billion trillion.
As you guys are doing that, so a little plug-in for math. And geometry. So you guys aren't even doing that yet. So what I was learning in that book, that cell biology, we were just looking at water, right? You guys know H2O, right? And I'm going to show it to you. This is awesome. Guys, this is not like interesting only. This is not just really, really awesome. It is like, this is what all of life depends on. It's really cool. And God did it. Oxygen, right? Oxygen atom bonded with 2 hydrogen atoms. Okay, ready guys? Real quick. They're bonded. Okay, the fact about math isn't just that there's 2 hydrogen to 1 oxygen, although that's math. There's an angle right here that's 104.5 degrees between those 2 guys. Listen to me. Oh, wow. Okay, ready? Ready? Really? You want to go that way? You want to go there? Swivl, follow me. Come to me. This right here, this angle, according to the authors of that textbook that students learn from, is one of the most critical facts about life. Okay, you're like, wait, why? You guys understand we need water? You guys get that? So here, if water did not have this angle for the bonds of the molecule right here, if it did not have that, you would not have the properties of water that we know of right now. So like everything from how much energy it takes to make water go up in temperature or down in temperature, how much, which is really cool, guys, that little creatures like water striders, it may seem kind of like, well, who cares, can float on water, surface tension. Yeah. The fact that water has a little bit of a negative charge and a little bit of a positive charge, therefore it's a universal solvent. That means it dissolves things easily. Like, you know, when you put sugar in water, what happens to that sugar? It dissolves. What happens when you put salt? It dissolves. When you put a lot of stuff, it dissolves in water. The fact that it's 104.5 allows that to happen. Plus, water bonds to itself very easily. You guys, water stays together. That allows water, when it gets into ice form, that it creates a level that doesn't cause it to sink in water. It causes it to rise. Imagine, guys, just think of this one little fact. If water, when it was frozen, sunk down, what would happen to every creature near the Antarctic regions or Arctic regions? They'd be crushed by ice. That doesn't happen. Plus, you get to enjoy nice drinks that are ice cold, and the cold can be distributed throughout the whole drink. Even just something little like that. The cold water, or the cold soda, the cold whatever, it goes down, which covers everything. So guys, that little piece of info, that degree, matters a lot.
What if it feels 105?
Yeah, it would change it. It would change the way that does everything else. Guys, I was reading, I'm like, you gotta be kidding me. Kidding me. God did this instantly. And this is part of not only big water, but it's in my body. Every little cell of mine has water in it, and that's making an effect. Awesome. Okay. You might need some food. Yeah, there is water in Gatorade, but I think you also need more pure water because it does get diluted with that Gatorade. There is like dyes and stuff like that. Salt, it might have a little bit too much than what you need, especially if you're not active. Like if you're just drinking Gatorade all the time, you're not burning off that salt. Okay, anyway, 7.51 times 10 to the Alex. What? Times 10 to the Hagen. 11th power. 7.51 times 10 to the 11th. I didn't hear it, Alex, and you looked a little bit hazy on that. Sorry. Number three. Write it in standard form. Standard form. Number 3. By the way, in that book, I was on chapter 2 out of, I think there's 30 chapters. I haven't even begun talking about cells.
Do you need to put commas when you have decimals?
You don't have to, but it does make it nice to read it. Yeah, I'll show you when you have a long decimal number. If you put commas, you can actually read it quicker. Although it's still hard to read that place value, but I'll show you. Let's do standard form here with number 3. Okay, I think most of you are getting done. We'll go with Jack. So I'm going to put 134. Sorry, I'll put it actually right here. 134. And what did you include with that 134, Jack?
So can I just give you the answer?
Yes, you may.
So 0.00000000001.
How many zeros?
8.
All right. 1, 2, 3, 4, 5, 6, 7, 8.
Is that like 134 over a trillion?
Okay, here's what you do. All right, remember commas, which are kind of weird. I'm going to put the commas where they would have gone, right? Okay. So I read, what place value is the last place value that I have here if I had like a 1? 10 billions, right? So I'm going to read this like this. This is tough, guys. I read it 134. You could read that part. And we were at 10 millions. So you would read 134 hundred billionths. That's how you do it. You go 1 up and put that TH on it. 134, what place value is this? 100 billionths. That's because I use the commas. Okay, anyway.
I don't think the commas help your.
The commas help me because you guys said 10 billions, right? That's a 10 billions place. So you'd read it just 134. You go 1 place value up, 100 billionths.
Could you do
You're
it
done.
without the commas?
Yeah, you can. You just have to keep going. I don't know. You just have to like find the place value. All right, guys, if you could do this next problem, you're like golden. And you pass the lesson.
What if we can't?
Number 10. Oh yeah, that one. Number 10. Because you already understand order of operations, you should have an idea what to do here, but we'll see how you do. How many numbers are there really?
3.
There's 3 numbers. The first one is 6 times 10 to the 13th. Then you have 4 times 10 to the 8th. Then you have 1.1 times 10 to the 5th. 3 numbers. You have addition and multiplication. What do you deal with first?
You want it standard?
Multiplication. Then you add.
Wait, you want it in standard form?
Yeah, you can write it in standard form and then scientific as well. Because you guys are good at that. Both. All right, so what I mean is you're going to deal with this first, do that. After you do that, then you can add it with the first number because you have to deal with multiplication before you deal with addition.
So with multiplication and division, you add and subtract exponents, but what if it's addition or
Adding?
subtraction?
Then you just have to have the same base of 10, power of 10. Then you just add the first parts, the decimal numbers. So did anyone get this right here?
4.4 times 10 to the 13th.
All right, you guys okay with that? All right, here's what I have. So I just multiplied it. Can I add these up the way they are?
Yes.
Yes, because I have the same power of 13. So all I have to do is add these two together. And then keep the same. Wow, that's like variables. Wow. Okay, and then that's not the correct answer because I don't like it. And it's not written in scientific notation. Yes, sir. What is it?
1.04.
1.04 times 10 to the 14th. That's scientific notation. Big or small number?
Big.
Big. Big. What are the biggest ones we've seen? In standard form. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, did I do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Read that number for me. Read that number for me.
104 trillion.
104. Okay, let me see here. Thousands, millions, billions.
Trillions.
104 trillion. That's it. Minus that. There you go. That's a big number, right? Yes, ma'am?
So why wouldn't you add the X?
On this last step right here?
Yeah.
Okay. I think you're ready for it. Okay. Do you have an answer?
I have a question.
Okay, go ahead.
If they weren't the same exponent, so like the city.
10 to the 13th, 14th.
Yes,
Mhm.
what would happen?
You can make this into the 13th by moving the decimal, or you can make that to the 14th by moving the decimal. Then you can add. Okay, here's a question, and here's the answer. It's a little convoluted, but see if you can follow me. Honors students, that means you should probably look at the screen, and we'll end with this. Okay, let's pretend that 10 to the 13th is really A. Can we do that? Is that okay? It's just A. So what's that worth?
A.
A. Okay, ready? Would this be called then 6A?
Yes.
Would this be called then 4.4A?
Yes.
How do you add 6A and 4.4A? You add the numbers in front and then you keep the same A, right? So it'd be 10.4A. So 10.4A. So did I do anything to change the exponent? No, because they're like terms, and you don't change that variable part. Hagen, can you explain it back to me? You can pick whatever letter you want. How about that? It doesn't even have to be A. It can be Z for zillion. Give her time to think. It's hard. Oh, Saved by the Bell, Hagen. Don't worry, I'll ask you tomorrow. No.